Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many 4-letter code words can be made using the letters in the word pencil if repetitions are not permitted? We already have the answer for this situation once we used the fundamental counting principle. We had that on the previous video. Please scan the same playlist and you would see the answer. But this time, we will be using here permutation, because permutation allows us to resolve a situation where, similar as this, repetitions are not permitted. The formula for our permutation is in this form, N, P, R, where N is the number of objects available and R is number of objects taken at a certain time. There are two conditions before we can use the permutation. Number one, as mentioned, there should be no repetition of objects on placements. So such as this, we have a 4-letter code word using the letters in the word pencil, and there are 6 letters. We are going to come up with 4 out of those 6, as long as we do not repeat the letter as we go through our code. In this case, our N here would be the number of letters in the word pencil. So we have 6 letters, and we are going to take 4 out of the 6 at a certain time, because we would like to have here a 4-letter code word. The second condition before we could say that it's a permutation or we can use permutation is that the arrangements of similar 4 letters in this case, when they are arranged differently, are counted separately. Say for example, if we use the letters P, E, N, and C, and we have another code word which is C, P, N, and E, same 4 letters, they are counted differently. Just like our 4-letter code words, of course, if you have 4 letters from the word pencil, we have different codes for that. Now that we have that, we are going to use the formula for our permutation. This is in this manner. We have n factorial over the result when we subtract n r from n, and you take a factorial of that. Okay, so we have to do this since our n is 6. We'll have here 6 factorial to be divided by 6 minus 4 factorial here. Now, please not forget that if we use factorial notation, this means we are going to take the result as we multiply all integers until n. That's n times the integer before that, n minus 1. The integer before n minus 1 is n minus 2 until we reach 1. Okay, this is our factorial here. That would mean our 6 factorial here is, or can be written as 6 times 5 times 4 times 3 times 2 times 1, or let me just simply write it into factorial. Again, it could be written as 2 times 1. No need to worry because it's until 1. Why is it that I'm stopping at 2? So that I could cancel out the result here, because 6 minus 4 is 2, and you have here factorial. Okay? So we have 2 factorial in our denominator. We have a 2 factorial here. If you would like to continue this as 2 minus 1, of course your 2 factorial is also 2 minus 1. Hence, we simply can cancel that. That would mean the number of 4-letter code words that can be made using the 6 letters in the word pencil, where repetitions are not allowed, will result to the product of 6, 5, 4, and 3. 6 times 5 is 30, times 4, that's 120, times 3, so you have 360 4-letter code words where the letters are not allowed to repeat. Now, if you would like to really see if this is the same as the answer as the previous video using fundamental counting principle, of course, we have this before. We have 4 placements because we have 4-letter code word. Using fundamental counting principle, we place here the number of letters that we can try here. That means we are 6 letters in the word pencil. Once we go to our second placement, and since repetitions are not permitted, whatever letter we use here can no longer be used to the next placements. Hence, we have here 5 to be followed with 4 because those two letters are already used, and we have here 3. The fundamental counting principle allows us to multiply all of this. Now, it's up to you which is easier for you, because this method, the fundamental counting principle, is just similar as this formula here for our permutation, which yields the same result of 360 4-letter code words. Of course, if you're going to use this, there's also the unique way to use in your use your calculator to solve for the result, but this is just for you to show your complete answers, and you can use both fundamental counting principle and the permutation this time. Again, don't forget the requirements for permutation to be used. Again, there should be no repetition, and the counting of arrangements using the same letters in this case will be counted separately. And that is for Count It In. Talking about getting the luck of the draw. For all in, subscribe now.